Namaste. Welcome to Indian Knowledge Systems Primer Course for Children. We are looking at a series of lectures in Indian astronomy. In this session, we will look at Khagola and Rashi Chakra. We have earlier learnt that Earth is situated on its orbit with an axial tilt and spins around this axis while also revolving around the Sun. And we also have a day-night experience because of the rotation of the Earth. Since this rotation is happening constantly, we also see all the celestial bodies rise and set in the east, towards the west. They rise in the east and set towards the west. The entire canvas of the sky thus is very rising and setting. However, what if some celestial bodies are themselves moving? How would we be able to map them and find them? How will we be able to locate them? Let's try to understand. So, we will try to understand this with the same analogy that we used in the earlier session. So, let's take an example of the rotating chair. We earlier saw when we kept on rotating, as we moved from right to left, the stationary objects that we saw were moving from left to right. That's fine. But now, let's say one of my friend who is here sort of moved from here to there. How would I be able to see? How will I map whether he's moved from one place or not? So, this is a very interesting event to identify. In such a case, what one can do is try to map them or project them towards a stationary background. Meaning, so if I move from here to here, so there is this wall and there is this other items that are present in this studio. But if my friend moves from this side to that side, definitely the background would have varied. So that is the mapping we are using to locate and identify and discern whether he has moved from one place to another or not. So now we are clearly able to understand, to discern whether an object is moving or not, we will need a frame of reference where things are relatively constant. So we have already understood what a frame of reference is, especially in the analogy of this rotating chair. The background that we see is the frame of reference. Similarly, from the observer's point of view on the earth, in order to track the motion of the celestial bodies, we will need a frame of reference. So, when we imagine this sky as the huge canvas, we will project a huge sphere of infinite radius in which the distant stars are also present. Such a huge celestial sphere, which can be used as a frame of reference, is called as Khagola. So, look at this diagram. If you carefully see, the earth is encapsulated in this big, huge sphere. So, the huge sphere is of infinite radius, so huge than the earth itself. It's an imaginary sphere. Please be mindful of that. So, this huge sphere is so big that even the distant stars are referred. I mean, they all can be mapped by looking at it from the earth. So, the earth here is considered to be located at the center of the celestial sphere. So, we already called this celestial sphere as Khagola. Khagola means, it is derived from Sanskrit. It means Kha means space and Gola means sphere. So, this celestial sphere can now be used as a frame of reference for understanding what? To understand the apparent movement of stars and other celestial body across the canvas of the sky. This Khagola, if you see, it has a lot of key components like the celestial equator, celestial pole and the ecliptic. We will now slowly unravel each of these key concepts. So, we will keep referring to this diagram all through this slide. So, better than the first diagram, now you can see the earth encapsulated in the Khagola very clearly. You also see a lot of differently colored discs line that keeps running around the celestial sphere. There is also an axis that is projected till the celestial sphere. We will try to understand what these are. Do you remember that we earlier discussed that the earth is slightly tilted with respect to the plane of its orbit around the sun. Hence, you can see the projection of the earth's equator upon this big sphere will be called as the celestial equator, will also be slightly tilted. That divides the celestial sphere, the Khagola, into two hemispheres. See, for us to imagine the Khagola, we need to also see that the visible dome, which is above the ground surface, that forms one half of the sphere, and the other half, which is actually the ground part in the earth, is the other hemisphere, and project this whole sphere into infinite radius. Like how we did the projection for celestial equator, we will try to understand what are the celestial poles. Take the terrestrial north pole, which is situated in the northernmost part of earth, and project it on to the Khagola. This forms the celestial north pole, and the same terrestrial south pole to be projected till the Khagola, that would form the celestial south pole. Now we see this green line. Do you all see? The celestial equator here is somewhat orangish in color, and then there is a green line which is also marked as ecliptic. We will try to understand what this ecliptic is and how is it formed. That is also an important concept. This line called ecliptic is very significant in Indian astronomy. For the observer on earth, that seemingly looks like the annual path of the sun. What is annual path of the sun? It is more like the sun travels through this ecliptic in 1 year. The daily path of the sun is called as the diurnal path. That will just be including events such as rising and setting. This ecliptic is actually the annual apparent path of the sun, because sun per se isn't moving, but when you observe sun from the earth, the point of view is situated on the earth, then the sun apparently moves because of the motion of the earth. So again, the celestial equator is the projection of earth's equator on the celestial sphere. Then we have the celestial poles and the projection of the earth's terrestrial poles into the spheres. This ecliptic we just defined. It is the apparent annual path of the sun on the Khagola. So why do we say apparent also? We just saw. It seemingly looks like it is changing. What is seemingly looks like it is changing? Sun. The sun seemingly looks like daily it is changing its path or position. But is that really so? That needs to be pondered over. This is very, very important to understand the positioning of the grahas. But what are grahas? This is a new word. Graha is loosely translated into planets, but as per Shabda Kalpadruma, graha is defined as Grinhati Gati Visheshan iti grahaha, which means Grinhati means that which takes, and Visheshan Gati is a special movement. So, that which takes a special movement is called as graha. This is the definition of graha. Hence, we cannot strictly, graha does not mean planet, but for convenience we loosely translate it into planet. Because when we say graha, we also include sun, moon and all, and these are not per se planets as per modern astronomy. Other than this, the rising and setting movement that we see and the background of the stars we will see, the planets will move according to that as well. So, the definition of graha we just saw is an astronomical one. There is also an astrological definition of graha. But in astronomy, we broadly understand graha to be the vastu which takes or which can have this special movement other than the usual diurnal motion of rising and setting. Because as it keeps changing its position, we can see that the point in its background with respect to the celestial sphere will also change. This is a very, very important concept to understand. See what is happening? Graha, which has the capability to have a special movement, because it keeps on moving. When we observe the graha from the point of view of Earth, for the observer, he will be able to see that the background which is from the Khagola will also vary. That is how they map that the positioning of the graha, that the graha is in motion. Let us try to understand this with a simulation.
Through earlier simulations, we have already come to appreciate that the sun rises at different spots on the horizon owing to the tilt of the earth and how the duration of the day and night will also change. Now, to position objects in the celestial sphere, we need a way to track their locations. Towards this, the Khagola and Rashi Chakra were created for the frame of reference. To appreciate these concepts, let us first understand that the background of the sun changes quite a bit. As we revolve around the sun, we will see that the background as we go around the sun keeps changing. And for the observer, it will be visible only if I remove the atmosphere. Once the atmosphere is removed, we see that on the 21st of March, the sun seems to be in the Meena Rashi, the Pisces. If at the same time 7 am, if I were to observe the sun, the position of the sun changes, which we already saw, but the background, the apparent background of the sun also changes. With every moving day, now we see the sun in the background of Aries or the Mesha Rashi. This constellation seems to be in the background of the sun now when it comes to May month. As we move through May month, almost in the mid of May month, sun has left Mesha Rashi and it has entered the Rishabha Rashi, the Taurus constellation. And over time, now the sun goes into Gemini or the Mithuna Rashi. And then the sun seems to be going through Kataka or the Cancer constellation. Then Leo or Simha. Then comes Virgo or Kanya. Like that, the sun's position seems to be changing with every single passing day. Then through Tula, Libra, then through Scorpius or Vrishchika, then the sun goes through Dhanur or Sagittarius. Then the sun seems to be going through Makara Rashi, then Kumbha Rashi, then Meena Rashi in the day where we started a year back. On 21st, we saw that the sun was in the same position of 2025 March. Now in 2026 March, the sun is in the same position. Thereby, whenever the revolution of the sun completes and it comes back to the same position, the Indian solar calendar celebrates the new year. We celebrate around the 14th April every year because that's when the sun starts entering the Mesha Rashi, leaving the Meena Rashi. So, thereby, every single month, the sun apparently seems to be in the background of different constellations. As we go around the sun in the orbit of 360 degrees, this orbit was divided into 12 segments. And these 12 segments of 30 degree each constitute a Rashi. The predominant constellation that falls in a 30-degree segment is given the name of that particular Rashi. Why? It helps us locate where the sun is, thereby locate where we are on the orbital around the sun. Hence, the Rashi Chakra forms the frame of reference to figure out where are the different celestial objects, the celestial bodies in the sky. Very interestingly, if you look at Mars, Mars is right now in the Mesha Rashi. So now Mars periodicity is quite different, and with each month you see the Mars now in Mithuna, then Kataka, then it goes to Leo, right? From there, from Kataka to Simha, it's going in different places, right? Every month. So all this it helps figure out the position of each planet or graha. Graha means that which keeps changing its position with respect to the background, the relatively constant celestial background. So the celestial background is a reference in all the grahas. Graha, though it's crudely translated as planet, does not really mean planet. But these are the celestial objects that have a motion with respect to the background of the stars. Their position keeps changing. Whereas the stars, the background is quite same. Why is it happening? Because these are the objects that are on the move. And as we are on the move, we see that the background of those objects keep changing. If we were to mark the path that the sun is taking throughout the year for an observer, it's actually we who are going around the sun, but throughout the year, the background of the sun keeps changing. And if we mark all that points and draw in the dome, that is called the ecliptic or the Bha Chakra or the Rashi Chakra. And it is through this ecliptic we understand the position. The entire celestial sphere is actually rising and setting, right? The entire observable hemisphere that we can see, the dome, and the unobservable, if I remove the ground, then that portion is also visible. So the entire thing is apparently rising and setting, and this position of the sun every day in the background it keeps shifting, right? At the same instant, now the sun is in the Makara Rashi. Like that, it keeps shifting day by day. Now, what is very interesting is that if we put together this path, this orange line called the ecliptic comes. And this ecliptic, right, is here. But we need a reference system to figure out the positions of the different celestial objects for which this entire sphere we call it as the Khagola. This entire sphere, right, as we can see it, this has been named as the Khagola. Onto this balloon or this infinitely large sphere, if I project the Earth's equator into this sphere, imagine the Earth to be a sphere and this entire Khagola, this celestial sphere, to be another ball, a ball inside a ball. And upon this celestial sphere, if I project the Earth's equator, that becomes the celestial equator. Ecliptic is the path that the sun takes, and the celestial equator is also visible in the dome right now that we are showing. These two things, one being the celestial sphere, upon it where there is the celestial equator and the ecliptic, they help locating different objects, celestial objects in the sky. So the celestial equator is the projection of our own Earth's equator onto the entire celestial sphere. Similarly, the North Pole, the celestial North Pole, this is this North Pole point to which Dhruva Nakshatra is close enough, right? This North Pole point, which is talking about the spin, is nothing but the projection. The celestial pole is the projection of Earth's own pole upon that outer large sphere. So, this creates a system of looking at and positioning a grid system to position different celestial objects in the sky.
So, to summarize the simulation, we just saw what is a celestial equator. The projection of the Earth's equator on the celestial sphere forms the celestial equator. Similarly, the projection of the Earth's terrestrial north and south pole onto the respective north and south area of the celestial sphere is called the celestial north pole and celestial south pole respectively. We also try to understand what ecliptic is by definition. We saw that ecliptic is the apparent annual path of the sun. So, this ecliptic is also called as Bha Chakra or Rashi Chakra. How is this green color ecliptic line formed? As we go around the sun in anti-clockwise direction. Look at this figure. As we go around the sun, look, there is the small blue color ball, spherical thing, that's Earth. The center one is the sun. So, as we slowly go around the sun in the elliptical path in anti-clockwise direction, at different points in time, we will be able to see sun being mapped to different constellations or stars in the Bha Chakra. That's the Bha Chakra. Because this is the Bha Chakra or the ecliptic is the apparent path that the sun takes, right? So, what happens? Is the sun here moving? No, sun is actually stationary. But since Earth is moving around the sun, for us to map, we are able to see that it is being mapped to appropriate constellations at one point in time. So, as we slowly move around the sun, for the observer here on Earth, it would look as if the sun is shifting its position. How do we know that? Because its background will keep on changing, and hence we connect all the constellations through which the sun goes, and we get this circle, the green color circle that we saw earlier, the ecliptic circle, and that circle is the ecliptic or Bha Chakra. So, this is how the 12 Rashis are also formed, mapping these to specific constellations. 12 constellations we have mapped on the ecliptic. But why do we have 12? As we go around the sun, there is a 360-degree motion that is happening to Earth. So, we divide these 360 degrees into 12 segments of 30 degrees each. That is how every Rashi is constituted. This constellation itself could be spanning vastly, but from the observer's point of view, it is going to only span for 30 degrees. The sun's, so each of the constellation, when we try to map the sun's position from Earth's viewpoint as an observer, they are all going to be equally spaced with 30 degree each. That is how we have the Indian Rashi system. So, the Bha Chakra is more circular path that connects all these constellations which represents the Rashis. Let us move on to the next slide. So, we have already understood what sort of phenomenon a day is. We understand that it is the sunrise and sunset. Traditionally and observationally, we have usually calculated the time between a sunrise and sunset as one day. Only in the modern times it is equated to the 12 or the strike of 12 in the midnight. But because we would want something substantiate and observational, it has always been kept, a day's calculation has been always kept from sunrise to sunset. That said, then how would we be calculating a month or a year? This beautiful verse by Nilakanta Somayaji in the famous Tantra Sangraha book very clearly elucidates that. Let us try to chant it. Saurabdhe bhaskarasyaiva jyotish chakra paribhramaha मासस्तु राशिभोगः स्यात् ayane chapi tadgati. So, Saurabde, Sau is sun. So, Saurabde, a solar year is, what is a solar year? They are trying to define what a solar year is. So, one understands that the time required to complete one full revolution by the sun around the Bhachakra, the ecliptic, is what is calculated as one solar year. Then what is Masa? Masastu Rashi Bhogah. When the sun spends time in one particular Rashi alone, that amount of time is called as Masa. So, we already have, from an observational point of view, we already know what is a day. Now, they have defined what is a solar year and what is a month as well. The period with which sun dwells in a Rashi is called as a solar month. Similarly, the sun moves in particular directions from the observer's point of view, the north and the south. These two are called as ayanas. We will talk about ayanas a little detailedly in the upcoming lecture. So, this verse, as we saw, beautifully captures the different categorizations of time and how do we measure them. So, in the Indian tradition, a new year starts when sun enters the Mesha Rasi, which is Mesha Sankranti. So, what happens after that? Let us go back to the Bhachakra. So, Mesha is Aries. So, it moves from, here is Mesha. So, Mesha is Aries. So, we will know that somewhere in April 14th is what we usually map as a New Year's. So, it moves, so it spends a good amount of 1 month in Aries, and from Mesha it moves to Rishabha and so on and so forth. So, once it comes back to Pisces and when it is about to enter Mesha, 1 full year would have been completed. So, this is how a solar year is being calculated using the Bhachakra. Now, how did we calculate the Masa? So, the whole 360 degree turn is divided into 12 segments, 12 equal angular segments, which gives us 30 degree each. So, angularly, the sun would be spending 30 degrees on each of the Rashis. That is how a Masa is calculated. But does that mean that all the Masas will have the same number of days? No, definitely not. Why? Because Earth, if you see, is moving around the sun in an ecliptic orbit. So, if it is closer to the sun, it will move faster. If it is far away from the sun, if it is in the farthest position, it will be moving slower. So, apparently, the sun would be seen to spend a lot of time in the Rashis that come in the farthest point. We will try to see what happens in the Masa, how the days are being calculated. So, we saw that the angular distance across the 12 Rashis is always going to be 30 degrees, because that is what would account to 360 degree revolution. But the time taken to traverse each of the Rashi will vary because the earth revolves around the sun in the ecliptic orbit. So, we saw that Rashi Bhoga, Masa becomes Rashi Bhoga. The sun, for how long does it spend time in one particular Rashi, becomes the number of days in that particular Masa. Let us look at this slide, which details the solar months or Saura Masa. We clearly saw the new year starts with the sun entering the Mesha Rashi. So, when it is spending time in Mesha Rashi, the Surya Siddhanta clearly describes that it will be spending 30 days. Sun spends about 30 days, 22 hours and 40 minutes. If you compare it with the modern values, the modern values now suggest 30 days, 20 hours and 56 minutes, which is pretty close. Do you also see that there is variation in the number of days across different Masas? For example, when the sun spends time in Tula Rashi, it will only be, the month will have only 29 days, 21 hours and 10 minutes as per Surya Siddhanta. But if it is in the but if it is in the Simha Rashi, it would be spending 31 days and 8 minutes. So this is a very interesting observation to be noted. Because the masa calculations are very observational, each masa, the amount of time spent is also pretty accurate and can be mapped to the astronomical event. It is not as straitjacketed as we see in the Western calendrical system. So, as per the verse, there is one more phenomenon that is being mentioned, that is the ayana, which we will deal with in detail in the upcoming lecture. Thank you.